Good day everyone. Welcome to this presentation. I am Captain Rani. In this video, I am going to take you through an already solved example number 10 from chapter 5 in Captain Subramaniam's textbook, Ship Stability 1. I am going to start with a slight variation of the same problem from his textbook. A vessel arrives at port X at the mouth of the river. Her displacement is 12,000 tons and arrival draft is 5.77 meters in water of relative density 1.020. She is to cross a bar upriver before entering port Y. The depth at the bar is 6 meters and relative density at the bar is 1.020. If her TPC is 25, find the minimum quantity of cargo to offload at port X so that she may cross the bar with an underkeel clearance of 0.5 meters. Now before I start, I would like to tell you that the word bar over here is referencing chart work. It is a term from chart work. It has nothing to do with the bar that you would have ashore where you have your drinks or whatever. Look at the picture at the bottom. You have the seabed, okay? And on the seabed, there is an accumulation of sand. As you see where I have highlighted. That accumulation of sand is called a bar, short form for sandbar. Now, up here, the clearance under the keel is different from clearance under the keel over a sandbar. Now, these sandbars are generally found at the mouth of the rivers or upstream in the rivers, and ships have to navigate with caution with sufficient under-keel clearance. In this problem, the under-keel clearance required over the sandbar is 0.5 meters. You have this ship of yours which has arrived at the mouth of the river in a port with a displacement of 12,000 tons at a draft of 5.77 meters, and the relative density at that port X is 1.020. Now she is going to cross the bar where the relative density is also 1.020. This is the slight variation from the actual problem that is in Captain Subramaniam's textbook. She is arriving at a port in relative density 1.020, and the water on top of the bar is also 1.020. She has a draft of 5.7 meters. The depth over the bar is 6 meters. Therefore, if she crosses the bar as it is without any discharging of cargo, she will have an underkeel clearance of 0.23 meters. That is the difference between 6 and 5.77 meters. What is required of the ship when she is crossing the bar is she should have an underkeel clearance of 0.50 meters. Therefore, she has to discharge some cargo at port X so that when she is on top of the bar, she will have an underkeel clearance of 0.50 meters. Now, as per the problem, they want her to discharge some minimum quantity of cargo. In fact, you can even pump out ballast in this case because she's got ballast as well as she's got cargo. So in effect, what it means is that you have to reduce your dead weight, whether it is actually ballast or whether it is cargo. But since the problem says cargo, we will talk about cargo. Now, this ship, go to the next slide, you will see that she is now over the bar and you have to have an underkeel clearance of 0.5 meters. Therefore, how much should she discharge? She should discharge something that is equal to the difference between the required underkeel clearance of 0.5 meters and the underkeel clearance that she would have if she did not discharge anything. That is 6 minus 5.77 meters, giving us an underkeel clearance of 0.23 meters. Therefore, how much should she discharge? She should discharge 0.5 minus 0.23, that is equal to 0.27 meters. She should lighten herself by 0.27 meters or 27 centimeters, and that multiplied by the dock water TPC will give us how much cargo has to be discharged or how much ballast has to be pumped out. So let us see the solution. As the relative density at port X and port Y are the same, freshwater allowance and dock water allowance are not required to be calculated. If the vessel was to cross the sandbar at the present draft of 5.77 meters, the UKC would be equal to 6 minus 5.770 meters equal to 0.230 meters, as I explained earlier. Required underkeel clearance UKC at the sandbar is equal to 0.5 meters. Therefore, the ship would have to discharge cargo and lighten to achieve a UKC of 0.500 meters. And it is not necessary to discharge cargo. If you have sufficient ballast, you can discharge your ballast also. So, required UKC 0.500 meters, present UKC 0.230 meters. Therefore, the difference is equal to, which is the rise that is required for the ship to lighten herself, is equal to 0.270 meters or 27 centimeters. Now, TPC given to us in the problem is 25 metric tons per centimeter, and TPC is always in salt water, and this has to be converted to TPC in dock water. To convert that, you divide the TPC in salt water by the relative density of salt water and you multiply it with the relative density of the dock water, which in this case is 1.020, therefore giving us TPC in dock water equal to 24.88 metric tons per centimeter. Therefore, the cargo to discharge is equal to rise multiplied by the TPC in dock water. The rise we have seen over here 27 centimeters and multiplied by the TPC of dock water we have seen over here 24.88. Therefore, cargo to discharge is equal to 27 multiplied by 24.8, giving us an answer of 671.8 metric tons. Now going on to the actual problem as is given in the textbook. We go to the next slide. The next slide, the problem states a vessel arrives at a port X at the mouth of the river. Her displacement is 12,000 tons and arrival draft 5.77 meters in RD 1.020. She has to cross a bar upriver before entering port. The depth at the bar is 6 meters and the relative density is 1.005. If her TPC is 25, find the maximum quantity of cargo to offload at port X so that she may cross the bar with an underkeel clearance of 0.5 meters. This is the actual problem, example number 10 from chapter 5 in Captain Subramaniam's textbook. So we start off again. The ship has arrived at port X. Her displacement is 12,000 tons. Her draft is 5.77 meters and the relative density of the water at port X is 1.020. If she were to go just like this without discharging anything, first and foremost, there would be a little bit of sinkage because she is going from dock water 1.020 to dock water 1.005. To find that sinkage, we have to calculate the dock water allowance. To calculate dock water allowance, we first have to calculate her freshwater allowance. And we know the formula for freshwater allowance is equal to displacement divided by 4 times the TPC, and the answer will be in millimeters. When we convert that, we will see that freshwater allowance is now converted to dock water allowance by multiplying it by the difference of the two densities, in this case 1.020 and 1.005, and dividing it by 0.025. Of course, you have to multiply this answer by the freshwater allowance, and this gives us the dock water allowance to be equal to 0.072 meters or 72 millimeters or 7.2 centimeters. Thus, as you saw earlier in the earlier slide, her clearance, underkeel clearance was 0.23 meters without application of the dock water allowance. That was 6 minus 5.77 meters. After applying the dock water allowance, we see that the underkeel clearance has now reduced to 0.158 meters. Now, having calculated that, we now have to calculate how much cargo we have to discharge so that when the ship is exactly over the bar, she will have a UKC of 0.5 meters. Thus, you see that now the ship is exactly over the bar and having a UKC of 0.5 meters, and she is floating in water of relative density 1.005. Let us see the solution on the next slide now. As the relative density at port X and port Y is not the same, freshwater allowance and dock water allowance are required to be calculated. Therefore, freshwater allowance equal to displacement divided by 4 times the TPC. Displacement is 12,000 divided by 4 times 25 equal to 120 millimeters equal to 12 centimeters equal to 0.120 meters. Dock water allowance is equal to freshwater allowance multiplied by the difference of the two relative densities divided by 0.025. When we put in all the values, we get dock water allowance equal to 72 millimeters or 7.2 centimeters or 0.072 meters. Therefore, the draft at the bar, if the ship were not to discharge any cargo, would be equal to 5.770 plus 0.072 equal to 5.842, because she would sink by an amount equal to dock water allowance. That is 0.072 as you have calculated above. If the ship were to cross in this present situation without discharging any cargo, her UKC would be equal to 6 minus 5.842 equal to 0.158 meters. Therefore, for the vessel to cross the sandbar at the present draft of 5.77 meters, the UKC including dock water allowance would be 6 minus 5.770 minus 0.072 equal to 0.158 meters. Required UKC as given in the problem is 0.5 meters at the sandbar. Therefore, the ship would have to discharge some cargo and lighten to achieve this UKC of 0.5 meters. Now, as I have said earlier, you do not necessarily have to discharge cargo. If you have ballast, you can also discharge your ballast. But since in the problem we have been asked about cargo, we will talk only about cargo discharge. Required UKC equal to half a meter. Present UKC is equal to 0.158 meters. Therefore, the difference is the rise that is required, and that is equal to 0.5 minus 0.158 equal to 0.342 meters or 34.2 centimeters. TPC in salt water is equal to 25 metric tons per centimeter as is given in the problem. This TPC in salt water has to be converted to TPC in dock water of 1.020. To do that, you have to divide the TPC in salt water by 1.025, which is the relative density of salt water, and multiply that with the relative density of dock water, which in this problem is 1.020, thereby giving us an answer of TPC in dock water equal to 24.88 metric tons per centimeter. Therefore, the cargo to discharge is equal to rise multiplied by the TPC in dock water, which is equal to the rise is 34.2 centimeters and the TPC in dock water is 24.88 metric tons per centimeter as we have calculated above, thus giving us an answer of 850.9 metric tons. Thank you very much, everyone. I am sure I have explained this problem well. If you like this presentation, give me a thumbs up, like, share my video as well as subscribe to my channel